Okay, guys, on section 8.1, we're going to introduce you to what are called polar coordinates. And so, your entire math life, you have grown accustomed to graphing ordered pairs in the form x, y, that have an x coordinate and a y coordinate. You know to go to the x coordinate first and then the y coordinate second and plot the point. Well, there is also what is known as the polar coordinate system. It's similar to the xy plane, but it works in radii and angles as opposed to x's and y's. And so all of these points are going to be in the form r, comma, theta, where r is a radius and theta is an angle. And so what we're going to do first is I'm going to show you just how you would plot a point in polar coordinates. And one thing that's important to remember, and we're going to see this as we go throughout the notes, is that polar coordinates are not unique. And what I mean by that is whenever we talk about points in rectangular coordinates, and I tell you the point 2, comma 1, there is only one way to plot the point 2, comma 1. It's right there. There's only one name for that point, and it's 2, 1. There's no other way to say it. But when we talk about polar coordinates, let's just say that I have a point right here that's at a radius of 2 and at angle 0. Well, not only can I call that 2, 0, but I could also call it 2 and 2 pi, because this is not only the angle 0, but it's also the angle 2 pi. I could also call it 2 and 4 pi. I could also call it negative 2 and pi, because whenever I have a negative radius, what that basically tells me is to go to the angle, which would be over here at pi, and instead of going towards pi, the negative in that radius tells me to go the other direction, which would put me right there at that same point. So there are going to be infinitely many ways to describe a point in polar coordinates, whereas there's only one way to describe that point if we're talking about rectangular coordinates with an x coordinate and a y coordinate. Okay, so if we look at letter A here, we got the point 4 and 2 pi over 3, and this is in the form r theta. And usually what we do is we start at the angle theta, and then we go that many radii out from the origin, or sometimes called the pole. Okay, so if I start at 2 pi over 3, 2 pi over 3 is right here. I'm going to start at the origin at 0, 0, and then I'm going to go out 4, and so that's going to put me at 1, 2, 3, 4 right here, and that's going to be point A. And just so you can see that, here is the origin or the pole, and then there's 1, 2, 3, and 4 radii out from 2 pi over 3. Okay, for letter B, we've got 3 and 7 pi over 6, so 7 pi over 6 is here. I'm going to start at the origin and go out 3 from the origin, and that's going to be where the point is going to be plotted right there, and that's going to be point B. For C, negative 2 and 5 pi over 4. Well, again, what this says is to start at the angle 5 pi over 4. 5 pi over 4 is not actually labeled on your graph here, so remember that 5 pi over 4 would be in quadrant 3, and that would be this line right here. And then the negative radius of a negative 2 means I'm actually going to go the other direction. So this point is actually going to end up in quadrant 1, and that's where C is going to be. So the negative radius right there tells me to go the opposite direction of the angle that is given. Okay, and then letter D, we've got 2 and negative pi over 6, and so negative pi over 6 would really be the same as 11 pi over 6, which of course is right here, and a radius of positive 2 means I'm going to go out that direction, and so there's 1 and there's 2. That right there is going to be my point, capital D. So 11 pi over 6, and then 2, and there's point D. Okay, we're going to do that a little bit later on as well, so if you need some more practice with plotting points and polar coordinates, then stay tuned. We're going to do some more of those on the back of the first page. Before we get there, let's talk about some conversions for polar coordinates. And so let the point P have the polar coordinates r theta and rectangular coordinates x and y. And here are the conversions that we're going to use whenever we want to convert back and forth between polar and rectangular. So make sure you know where those are in your notes. Make sure you have them next to you as you're working problems and as you're trying to make these conversions. And we're going to start doing that on this next page. So example 2, we're going to complete the following table and then plot the points on the polar coordinate plane provided. And so we're just going to start doing some things here. As far as converting, we're going to start to fill in this table. I've given you one of the pieces of information for each of these 5 points. I've gone ahead and labeled all of these A, B, C, D, and E. And so we'll just start with point A. We'll fill in the rest of the columns, and then we'll move to B and to C, and etc. Okay, so starting with polar, we're given in polar that this has a radius of 3 and an angle of 5 pi over 3. Now, the first thing that we want to do, and really, you can go in whatever order that you want here. It doesn't really matter the order that you go in. But the first thing I'm going to do is I'm actually going to do that very middle column where it says that we want to do an angle that's in polar, but with the theta that's less than 0. Or another way to say that is with a negative angle. And so the way that we're going to do that is we're just going to subtract 2 pi from our angle so that we get the same point in polar coordinates just with an angle that's negative. So if I've got 5 pi over 3, then I'm going to subtract 2 pi, which is going to be, of course, 6 pi over 3, and that's going to give me negative pi over 3. And so this point in polar coordinates with a theta that's negative is going to have the same radius and an angle of negative pi over 3. Okay, just as easily for this column right here, polar but with a theta of greater than 2 pi. In that particular case, I'm going to add 2 pi. So if I add 6 pi over 3, then that's going to give me 11 pi over 3. And so this angle in polar coordinates with a theta that's bigger than 2 pi will be 3 and 11 pi over 3. Okay, if I want r to be negative, well then obviously it's going to be negative 3. And then I've got to be able to put that basically on the opposite side of the circle. Well, to get to the opposite side of the circle, what we're going to do is we're either going to add or subtract pi from our original angle. Think about it. 3 and 5 pi over 3 is going to be right here. So this is going to be point A if you want to go ahead and plot that. And to get to a point which would be the same point just with a negative radius, we need to be at the angle that is diametrically opposite to 5 pi over 3, which is going to be 2 pi over 3. And how could I get there without having to graph that? I could just take my 5 pi over 3 and subtract 1 pi. And that's going to give me 2 pi over 3, which as you can see is the same angle that we would point to if we were on the opposite side here so that we would get to A with that negative radius. So this is going to be 2 pi over 3 as my angle with a negative radius of negative 3. Okay, and then finally, the rectangular coordinate for this. And so, again, what are we given? We're given an r, and we're given a theta, and we want to get to an x and a y. So these rectangular coordinates are going to be in terms of x and y. And so what do I know from the previous page? I know that x is equal to r cosine theta. And so this is going to equal to r, which is 3, times cosine of theta, which is 5 pi over 3. Cosine of 5 pi over 3 is positive 1/2, and so 3 times 1/2 is going to give me an x-coordinate of 3/2. And for the y-coordinate is going to equal to r sine of theta. And so that's going to equal to r, which is 3, times the sine of 5 pi over 3, which was our theta. And that's going to be negative square root of 3 over 2. So this will end up being negative 3 square roots of 3 divided by 2. And that's my y-coordinate whenever I do the conversion. So negative 3 times the square root of 3 divided by 2. Okay, and that'll take care of point A. I'm probably going to run out of room here. I have some room to do point B, but I'm probably going to have to come up and erase what I just did for point A, so just make sure that you have that copied down somewhere, and if you need to attach another sheet of paper to these notes, then by all means, let's go ahead and do that. Okay, in letter B, we're starting with the rectangular coordinate. We need to move, first of all, to polar coordinates. So what I know is that this 2 is x, and that negative 2 is y, and in order to get r, we're given a formula on the previous page. R is equal to the square root of x squared plus y squared. Okay, which is going to equal to, in this case, the square root of x squared, which would be 4, plus the y squared, which would be negative 2 squared, which is also 4. And so this is going to be square root of 8, which will reduce whenever you simplify the radical to 2 square roots of 2. Okay, we also know that tangent of theta is equal to y over x. And so what that means is that theta is equal to the tangent inverse of y divided by x. Okay, so this is going to equal to the tangent inverse of y divided by x. So that'll be negative 2 divided by 2, which of course will reduce to negative 1. And then that is going to give me an angle of negative pi over 4. Okay, now that angle is already negative. So I'm actually going to put this in the third column where the angle is supposed to be negative. And so I'm going to have here 2 square roots of 2 and then negative pi over 4. Okay, so hopefully you can see it okay. I might erase that actually and give it another shot here. Negative pi divided by 4. That's a little better. And the reason, again, that I'm putting it in that column is because the angle that I got when I did the formula was a negative, and so that's why I went ahead and put it in that middle column. Now, if I want that second column for just regular polar, what I can do is I can add 2 pi. So negative pi over 4 plus 2 pi would be 8 pi over 4, and that's going to give me 7 pi over 4. And so in this column, I can put 2 square roots of 2 and 7 pi over 4 as my point. If I want a theta that's greater than 2 pi, then I can add another 2 pi, and that's going to end up giving me 15 pi divided by 4. So here this will be 2 square roots of 2 and 15 pi over 4. And then finally, if I want that radius to be negative, then I already know what it's going to be. It's going to be negative 2 square roots of 2. And then from 7 pi over 4, I want to subtract pi. So when you do a negative radius, what you end up doing is you either subtract pi or you add pi, depending on what quadrant you're in. This point's going to be in quadrant 4, because if you think about it, square root of 8 is a little bit less than 3, and then 7 pi over 4 would be here in quadrant 4. And so a little bit less than 3 would be, let's see here, 1, 2, probably somewhere like right there would be my point B, and that's in quadrant 4. And so since that point's in quadrant 4, I want to move that angle to be in quadrant 2, which means I want to subtract pi. So 7 pi over 4 minus 1 pi ends up giving me 3 pi divided by 4. And so that's going to be my angle for my point with a negative radius, 3 pi divided by 4. Okay, go ahead and make sure you got all that copied down. I'm going to have to erase this so that I can get some more room here to do the final 3 points. And maybe we should try a different color at this point just to maybe give it some contrast so that we can see what's going on. So polar, in letter C, we're given a polar point, polar coordinates with a negative radius. Okay, so negative 3 and 5 pi over 4. And so let's just go ahead and plot that real quick. If I start at 5 pi over 4, that's actually in quadrant 3. But the negative radius means I'm going to go the opposite direction towards pi over 4. And so that means that I'm going to have, let's see here, going out 3, 1, 2, 3. This is going to be point C right here. And so just a regular point is going to be positive 3 and pi over 4. Okay, now if I want the angle to be negative, I can take that angle that I just got, pi over 4, and I can subtract 2 pi, which would be 8 pi over 4. And 1 minus 8 is going to give me negative 7 pi over 4. So this will be 3 and negative 7 pi over 4. If I want an angle that's bigger than 2 pi, then what I can do is I can take that original angle and I can add 2 pi to it. And that's going to give me 9 pi divided by 4. Excuse me. And so this is going to be 3 and 9 pi over 4. And then finally, we want to do the conversion. And so remember, for the conversion, we have an r and a theta. So to get an x and a y, I know that x is going to equal to r cosine of theta, which is going to equal to 3 times the cosine of pi over 4, which will equal to 3 square root of 2 over 2. So that will be my x coordinate. And then my y-coordinate will be r sine of theta. And so that will also be 3 times the sine of pi over 4, which is also square root of 2 over 2. And so my y-coordinate just so happens on this particular problem to be the same as my x-coordinate, 3 square roots of 2 divided by 2. Okay, for letter D, let's see if we can pick another fun color here maybe, letter D. We're starting with a negative angle, so 4 and negative pi over 3. So what I can do is I can come here to the second column and I can go ahead and put a positive 4 as my radius. And then to get my angle, I can just take that given angle and add 2 pi to it to get the coterminal angle. And that's going to be 5 pi divided by 3. So this will be 5 pi divided by 3 here. And then to get the polar coordinate with an angle of greater than 2 pi, I can go ahead and just add another 2 pi. And that's going to give me 11 pi divided by 3. So this will be 4 and 11 pi divided by 3. And then for a negative radius, I know that the negative radius would obviously be negative 4. And then I want to do the angle that is diametrically opposite to 5 pi over 3. So 4 and 5 pi over 3, these points, actually end up being plotted really close to one another. I believe D would be right here. So real close to A and B. And the angle that's diametrically opposite to 5 pi over 3, we did that before, in point B is going to be 2 pi over 3. And again, how did I get that? I took my angle from column 2 and I just subtracted pi from it, which would be, of course, 3 over 3, which ends up giving you the 2 pi over the 3. Okay, and then to do my conversion, back to rectangular coordinates, again, I know that x is equal to r cosine of theta, which in this case will be 4 times the cosine of 5 pi over 3, which is equal to a half. So 4 times a half would be 2. And the y-coordinate is going to be r times sine of theta, which will equal to 4 times the sine of 5 pi over 3, which is negative square root of 3 over 2. So negative 4 square roots of 3 over 2 ends up becoming, when you reduce, negative 2 times the square root of 3. Okay. And then finally, for point E here, I'm going to, again, erase. So please make sure that you have this all copied down. If you need to pause the video, then by all means, feel free to do that. And let's finish up this chart with point E here. So maybe another different color here. How about purple? Okay, point E. We're starting with this point down here, an r and a theta of 13 pi over 6. And so what we can do is we can start by getting this second column by subtracting 13 pi over 6 minus 2 pi, which would be 12 over 6. And that's going to be 1 pi over 6. And so we're going to have 2 and pi over 6 in that column. Then we can go ahead and get this column by subtracting another 12 pi over 6 so that we get a negative angle, and that would be negative 11 pi divided by 6. So this would be 2 and negative 11. Sorry about that. Hold on just one second. Negative 11 pi over 6. There we go. And then for the negative radius, we're going to have negative 2. And then we're going to have the point that's diametrically opposite of pi over 6. Okay, so diametrically opposite of pi over 6 means that we're going to add a pi in this case, since pi over 6 is in quadrant 1, by adding 6 over 6. That's going to put us into quadrant 3, which is going to be opposite of pi over 6 at 7 pi over 6. Okay, so for this column, what you're doing is you're either adding or subtracting pi. Basically, for these other columns, you're either adding or subtracting 2 pi, adding or subtracting 2 pi, adding or subtracting 2 pi. And then for this last column, you are using the conversion. So what do we know? We know that x is equal to r cosine of theta, which in this case will be 2 cosine of pi over 6, which is 2 times the square root of 3 over 2, which just ends up becoming square root of 3 as the x-coordinate. And then the y-coordinate will equal to r times the sine of theta, which is equal to 2 times the sine of pi over 6, which is 2 times 1/2, which ends up becoming 1. And that's the y-coordinate of that point. If we were going to plot that, then we would go to pi over 6, which is right here, and then go out 2 radii, which would end up being right here, and that would be point E right there. Okay, so that's kind of a long example. You're not going to have one like that in your homework necessarily, but I like to give this problem just because it gives you a lot of practice in converting between different ways of, expressing polar coordinates, and then also converting those polar coordinates back to rectangular coordinates, and the one example of point B where we converted rectangular coordinates into polar coordinates. And so for the remaining examples, we're just going to kind of, do one of those, not necessarily all of them, as we look at these problems. So it says to convert each polar coordinate, which is in the form r theta, into rectangular coordinates, which is in the form of x and y. So if we were going to do this, we would have x is equal to r cosine of theta, okay, which in this case would equal to negative 6 times the cosine of 3 pi over 2. And cosine of 3 pi over 2 is 0, and so this x-coordinate is going to be 0. And the y-coordinate is going to be r sine of theta, which will be negative 6 times the sine of 3 pi over 2. The sine of 3 pi over 2 is negative 1, so negative 1 times negative 6 gives you positive 6. And so this is the point in rectangular coordinates 0 and 6. And it might have actually been easier to plot that point first. And you might not have had to have even done these conversions. Okay, so if you just think about this real quick, 3 pi over 2 is down here on the bottom. And negative 6 means you're going the other direction 6, which is going to be that point right there. And you can see that in rectangular coordinates, we would call that the point 0, 6. So in this case, it might have actually been easier and faster and more efficient just to plot the point and then go based off of that. The same is probably true on letter B. Be careful because this looks like a rectangular coordinate already. But remember, this is an r and a theta. And so if I were to use the formulas, x is going to equal to r cosine of theta, which is going to equal to 2, since cosine of 0 is equal to 1. And then y is equal to r times the sine of theta. Sine of 0 is 0, so this ends up being 0. And so this is one of those interesting cases where the polar coordinate and the rectangular coordinate are exactly the same. Okay, letter C, again, same idea. We're going to have our conversion here. X is equal to r times the cosine of negative 5 pi over 3. Okay, and cosine of 5 pi over 3 is going to be a half. And so negative 5 times a half will be negative 5 halves. Y is going to equal to negative 5 times the sine of negative 5 pi over 3, which is square root of 3 over 2. And so this is going to be negative 5 times the square root of 3 divided by 2. And so this is the point in rectangular coordinates, negative 5 halves and negative 5 square root of 3 over 2. Okay, letter D is a calculator problem. You're not going to be able to do this really without a calculator. So if you don't have your own calculator, you can just hop on Google, hop on your phone, try to download something that will let you do sine of 165 and cosine of 165. And so my x-coordinate is going to equal to my radius times the cosine of my angle, 165. And so the reason we need a calculator is because we're not real sure what cosine of 165 is without a calculator. And typing that into the calculator, you get negative 4.25. And then the y-coordinate will be r times the sine of 165, which is going to be 4.4 sine of 165. Typing that into the calculator real quick, going to 2 decimal places is going to give me 1.14. And so in rectangular coordinates, this polar coordinate is negative 4.25, comma 1.14. Okay, so make sure you have your calculator handy in order that you can do those. Okay, on example 4, we're going to go the other direction. So we're going to convert from rectangular coordinates, which is an x and a y, and go to polar coordinates, which is an r and a theta. So we're going to need 2 things here. We know that r is equal to the square root of x squared plus y squared, and that theta is equal to the tan inverse of y divided by x. Okay, so again, in some cases, it may be just easier to plot the point and then go based off of that. So convert from rectangular coordinates. So if I were going to plot the point 14, 0 in rectangular coordinates, I would go 14 out on the x-axis, and I'm not going to draw 14 little tick marks, but you get the idea. And then 0 on the y-axis would give me a point there. And so if I want that in in polar coordinates, I need a radius. Okay, well, the radius is going to be this distance from the pole, which we already said was 14. And then the angle here is 0. And so this ends up actually being the exact same point. It has the exact same name in polar coordinates as it does in rectangular coordinates. Okay, negative 13 and 0. Negative 13 would be over this direction. And so this time that distance, if we want to give it a positive radius, would be 13. And then what angle would this be right here? Well, that would be pi, right? So we're going to put pi as our angle. And so this point is going to have the rectangular coordinates 13 and pi. Okay, letter C, probably not going to be able to get away with just graphing that. And so we are going to have to use these equations here to make this conversion. And so let's go ahead and do that. So if we want the radius, then that's going to equal to the square root of x squared, which is 3. So 3 squared is 9, plus that y-coordinate squared, which when you square that, and you're more than welcome to use your calculator to do that, you're going to end up with 27. 9 plus 27 is 36, and so that will be a radius of, not sure where I got 4 from, 6. Square root of 36 is 6, sort of a laughable moment there. So the radius is 6, and to get the angle, we're going to take the inverse tangent of y divided by x. So negative 3 squared to 3 divided by 3, which is going to end up reducing to negative root 3, which will equal to negative pi over 3. And notice how we wanted to give our answer. We wanted to give our answer with a positive radius. Well, I've got a positive radius right there, and an angle between negative 2 pi, and this should say 2 pi, by the way, not 2 theta. Sorry, that's a typo right there. So you can cross that out on your notes and just put 2 pi. And notice that we've got an angle that is between negative 2 pi and 2 pi. So we can go ahead and put our answer here, 6 and negative pi over 3. But as we know, there are going to be multiple correct answers to that because it's real easy to change that angle just by adding or subtracting 2 pi. You wouldn't want to subtract 2 pi in this case because that would put you outside of the parameters for this particular problem, but you could definitely add 2 pi. That would be perfectly fine because that would put you at 5 pi over 3, and that would still be between negative 2 pi and 2 pi like this problem wants it to be. Okay, example 5 and 6. We're going to convert equations back and forth between rectangular and polar. So we've learned how to convert points. Now we're going to learn how to convert entire equations, which is going to be pretty cool just using our formulas. So for letter A, we have x and y. We want to convert to something in terms of r and theta. And so what do I know about x? I know that x is r cosine of theta. And I know that y is r sine of theta. Okay, and so what this is going to end up being, and usually what we want to do is we want to end up making this equal to 0 in some cases. That's what this one is going to be. We're going to end up actually equaling this to 0. If I square out this left-hand side, I'm going to get r squared cosine squared of theta, and then minus 20r sine of theta is equal to 0. That's going to be a multiple choice question on your online homework. So you're going to see it in this form where the equation is put equal to 0 by moving everything to the left-hand side. That's kind of why I'm doing it that way on the notes. Okay, letter B. We're again going to just plug in what we know for x and y. So we know that x is r cosine theta. We know that y is r sine theta, and this is going to equal to 1. And so here's what I can do now is I can take this r and multiply them together and get r squared. So this is going to be 19r squared sine theta cosine theta is equal to 1. Now I mentioned this is a multiple choice question, and so it's going to do something a little goofy here. I don't know that I would necessarily do this, but just to show you kind of what they did is they used an identity. And so here's the identity that they used from the previous chapter, that sine of 2 theta is equal to 2 sine theta cosine theta. Okay, well, if you look here, this is what we have right now. We do not have the 2. So what we're going to do is we're going to divide that to the other side so that it cancels, and we have what we have here in this equation. And so we're going to substitute that out for sine of 2 theta divided by 2 is equal to 1. And so what that ends up giving you is sort of a nice final answer would be 19 divided by 2 r squared sine of 2 theta is equal to 1. Now, again, I don't know that I would necessarily go that far and do that using that double angle identity, but that's what they did, and so I'm just trying to give you an insight of what they're doing in order to get the answer that they got. Okay, letter C is going to be significantly easier than what we just did in letter B. Y is equal to 9. What do we know about y? Well, in polar coordinates, we know that it's r sine of theta. So this is going to be r sine of theta is equal to 9, and there's literally nothing else to do to that equation right there other than circle it and move on with your life. Okay, in example 6, we're going to go the other direction. So we have polar equations here in A, B, and C. We're going to convert those to rectangular equations. And so what do I know? I know that r squared is equal to, not square root, I'm sorry about that. Let's check that. X squared plus y squared without the square root, and that's because I have a squared on this right here. Okay, and what else do I know? I know that x is equal to r cosine theta. I know that y is equal to r sine theta. And so if you look at A, we're really close to being able to use some formulas. But we're not quite there yet, because if you look at this right-hand side, we've got a sine theta, but we're missing an r. And for this r right here, we're almost to the point where we could use this formula, except we would really need another r there so that it was an r squared, so that we could replace it with x squared plus y squared. And so how do we get an r on both sides of the equation when we need one? Well, we just multiply both sides by r. So multiply the left-hand side by r, you get r squared. Multiply the right-hand side by r, and you get 5r sine theta. And so now what do I know? I know that r sine of theta is y, and so this is going to be 5y. And what do I know about r squared? I know that it's x squared plus y squared. Okay, the last thing we want to do for all three of these examples is we do want to put them in what would be called general form, which is set equal to 0. And so just moving that 5y over will give you your final answer right here. Okay, in letter B, we've got a similar issue. We are missing an r on that right-hand side. We're almost able to say that this right here is 9x, but we're not quite able to say that because we don't have an r. So we're going to multiply both sides by r, and so that's going to end up giving me r cubed is equal to 9 times r cosine of theta. Now, we sort of did something not so great on the left-hand side. Now we have r cubed, and we don't know what r cubed is. We know what r squared is by this little conversion formula here. So here's what we're going to do. We're going to be really clever with our exponents, because r to the third, stay with me here, is really the same thing as r squared raised to the 3/2 power. Now, why in the world did I do that, and why is that a true statement? Let's start with why that's a true statement first. Why is that a true statement? It's because when I raise a power to a power, I multiply these two powers. And so if you multiply 2 times 3 over 2, the 2's cancel, you end up with just a 3 as the exponent, and that's exactly what we had in our first step here after we multiplied that entire equation by an r. Okay, so hopefully you're with me on why that's legal. Now, why was that helpful? Because now on the inside of the parentheses, I know that r squared is x squared plus y squared. And so I can now write that in rectangular form, x squared plus y squared to the 3/2 power equals to, now what do we know about r cosine theta here? We know that r cosine theta is equal to x. And so that's going to equal to 9x. And so the last thing is we just want this equation to equal to 0. So we're going to subtract over the 9x and set it equal to 0. And that will give us the final result that we want for our answer. Okay, finally, letter C. R is equal to 8. And so what do I know about r? I know that if r squared is equal to x squared plus y squared, that if I, let's try that not in highlighter, but actually in pen. If I take the square root of both sides, I know that r is equal to the square root of x squared plus y squared. And so this is going to say square root of x squared plus y squared is equal to 8. And if we want to get that into general form, then we're going to square both sides and get x squared plus y squared is equal to 64. And so x squared plus y squared minus 64 will equal to 0, and that's how you'll want to write the result and the final answer. Okay, that's going to do it for section 8.1. Feel free to ask me any questions that you may have. Go back, rewatch the video, anything that didn't make sense, and I'll be happy to answer any questions that you guys have, and I'll see you guys pretty soon here for section 8.2 a little bit later. Bye.